So I have 1.01 times 10 to the 23rd atoms of oxygen in a pure water sample. And when this is decomposed, how many grams of hydrogen gas will we get? So I'm going to start with atoms of oxygen on the one side, and I'm going to be going to grams of hydrogen gas. All right, so this is weird starting. Atoms of oxygen in pure water sample. Pure, that means nothing else is in there. It's not a solution. So that means my water sample is just my Mickey Mouse molecules. Okay, let me just write one of those ones so you can see it a little clearer. We have oxygen, and then his little ears are those hydrogens. Okay, right? So in pure water sample, there's just water in there. So that means there's one oxygen atom for every one molecule of water. So we're going to need that relationship in there, and that one's not on our mole island map. That's just a visual one when you're breaking things down. So let's do a little side quest. If I have H2O, that's a molecule. Okay. If I have magnesium, that's an atom. So if the problem gave you molecules of something and you wanted to go to moles, you could use Avogadro's number. But if they gave you atoms of magnesium, then you could go to moles with Avogadro's, because a magnesium is an atom and a water is a molecule. But here we have an oxygen atom. Okay? It's not by itself, it's in water. So we have to first go oxygen atoms, where there is one atom of oxygen for every one molecule of H2O. So in this case, it's a 1-to-1 ratio. So if I had 10 atoms of oxygen, I'm going to have 10 molecules of water. So when you did your learning check, if you had just skipped that step, you actually would be okay here. That's why it's important to watch the video, because it could have given you hydrogen atoms, in which case you would have had to have a 2 on the bottom there, and you would have divided everything by 2 at the end. But today you're going to luck out because it is going to work directly. But I'm still going to put it in here because I want to make sure my units cancel. So I have to go from atoms of oxygen to moles of water. This is the oxygen in water. There's no Brinkelhoff. It's not hydrogen peroxide. Hydrogen peroxide is H2O2. Okay? It is just pure water, so we're not Brinkelhoffing. Atoms of oxygen to molecules of water. And that's when our mole island comes into play. We have molecules of water, which is down here at particle island, and we want to get to moles because you always have to get to moles. Oh, sorry, I'm on B. It looks exactly the same. It just has A's instead of B's. Okay, particle island, divide by Avogadro's to get to moles. Divide by Avogadro's to get to moles of the first chemical, moles of water here. Now we have to convert from water to hydrogen gas. We need the USS mole ratio. And that's going to give us moles of B. USS mole ratio gets us to moles of B. And then from moles of B, we can get to gram island, because we're going to go up to gram island, multiply by molar mass. It's the same process. Okay, we just have one extra step at the beginning. Atoms of oxygen, 1.01 times 10 to the 23 atoms. Okay, atoms goes on the bottom because it's what we know. Remember, it's always unknown units go on the top and known units go on the bottom so that we can cancel. We know we have atoms, so atoms goes on the bottom. Where do we want to get to? Molecules. So molecules of water goes on the top. There is one molecule of water for every one atom of oxygen, H2O, one oxygen. Okay, so now we're at molecules of water. Next step, divide by Avogadro's number. 6.02 times 10 to the 23rd molecules in 1 mole. Okay. The known was molecules. What we wanted to get to was moles. Now we're still at moles of H2O. But now we have to convert to moles of hydrogen gas because that's what we're looking for. Okay. What we know is water, so moles of water goes on the bottom. What we're trying to find is hydrogen gas. That's our last step. So moles of H2 goes on the top. Oh, our mole ratio. What do we need for that? Balanced chemical reaction. Let's go back to the problem because we never set it up. Okay. We have 1.01 times 10 to the 23rd atoms in oxygen in a pure water sample when decomposed. Okay, so when the water was decomposed, so we started out with water as a liquid. It was decomposed. When something's decomposed, we know we split it into its two halves, hydrogen and oxygen. Brinkelhoff. Got to make those both have their twin and make them gases because we know both hydrogen gas and oxygen gas at normal conditions, they're going to be in that gas form. Okay? And then remember, always have to balance your equation. 4 hydrogens, 2 oxygens, 2 oxygens. So now we have our mole ratios. We know there's 2 moles of water break down to make 2 moles of hydrogen and 1 mole of oxygen. 2 moles of hydrogen, 2 moles of water. Well, this one's kind of nice because now I can cancel my moles of hydrogen and I can cancel my 2 2's. So if I stopped right here, I would have moles of hydrogen because all my other units are gone, all my other species are gone. But I'm not done yet. I need to get grams of hydrogen. What I know, I'm multiplying by molar mass. There's 2.02 grams of hydrogen in every mole of hydrogen because the periodic table has hydrogen at 1.01 grams per mole or 1.01 atomic mass units. All right, and now finally, I can cancel. All right. Do I have anything left over? No, I'm just left with grams of hydrogen, which is exactly what I need to solve the problem. So these are my units, and H2 is my species. So now the only thing left to find is that magnitude. Okay, the magnitude just means the number or the value, and make sure it's in sig fig proper form. All right, so let's see. We have 1.01, then that second EE button, 23, and hit enter. See how it converted on mine, because I'm in engineering, I guess, format, to 101 times 10 to the 21. I always hit the enter just to make sure that I didn't mess up my decimal place or I didn't mess up my EE button to make sure I'm on the right track. 1.01 times 1 times 1 times 2.02. Okay, so that means my top number is going to be 2.0402 times 10 to the 23rd. That's the result of multiplying across the whole top. And I'm going to be dividing what's on the bottom. So let me see what's all on the bottom. 1, and because I canceled, there's only one thing on the bottom, 6.02 times 10 to the 23rd. So I can just take my top number divided by 6.02, second EE, 23. If you're not going to do that, make sure you have parentheses after the divided sign, and you have the parentheses after times 10 to the caret. Put in extra parentheses there so that you are not flipping the exponent to the numerator. And my answer is 0.3389. Okay, and I need to put that into how many sig figs? 3 sig figs. Okay. So first 3 numbers are important. That 9 is not important, so it's going to go away, but it told me I need to round. 0.339. 339 grams of hydrogen are my answer.